All right, guys, what's up? It's day 66 of 100 Days of LeetCode. We got our LeetCode hard. It's the first LeetCode hard, and it's a big day. It's going to be exciting. It's number 295, find median from data stream. We're going to be using heaps today. I'm going to assume you know what a heap is. If you don't know what a heap is, I'm going to link some stuff in the description that you can read and learn a little bit more about heaps. It's basically just a type of tree in which you always have the minimum or the maximum value at the top of the tree, and that's going to be very useful for our solution. But let's get right to it. Let's start with the description. So the median is the middle value in an ordered list. If the size of the list is even, there's no middle value, and the median is the mean of the two middle values. For example, an array of 2, 3, and 4, the median is 3. An array of 2 and 3, the median is 2.5 because we take 2 and 3, take the average, which is 2.5. So we want to implement the median finder class. So this is the constructor. Add num is going to basically add a number to the object, and find median is going to return the median of all the elements so far. And answers within 10 to the negative 5 of the actual answer will be accepted. That's fine. We won't have to worry about that. But yeah, this is just an example of a little situation. Yeah, it's pretty straightforward, right? We add 1, we add 2, we get 1, 2. We get the median, we get 1.5, of course, because the average of 1 and 2 is 1.5. We add a 3, we get 1, 2, 3. The median is now 2 because it's the middle number, because we have an odd number. Okay, so let's get to the implementation. So we're going to be using two heaps. And let's write the code. So in Java, we can use priority queues. In other languages, you can implement similar data structures. But yeah, one we're going to call smaller, and one we're going to call bigger. And I'll explain that in a sec. Oops. And we're also going to use a Boolean value called isEven. Okay, so smaller is basically going to be a max heap of all the numbers that are smaller than basically our median. Bigger is going to be a min heap of all the numbers that are bigger than our median, right? We're actually not even going to compute the median until we run this function, but it'll make sense when I actually implement it. And then isEven is basically tracking whether or not we have an even number of sort of integers in our object. And that's going to be useful when we decide whether or not to just return one number or return one number, which is actually the computed average of two different numbers. So now what we're going to do is, in our constructor, we're going to say smaller is a priority queue of integers. And we have to pass in this argument, collections.reverseOrder, because the default priority queue in Java is actually a min heap, and we want smaller to be a max heap. And then bigger, we can just initialize like so, right, with no arguments. And then we're going to say isEven is equal to true. And the reason why it's equal to true is because right now we have zero integers, in our object. 0 is an even number. That makes sense, right? Okay. So now when we add a number, at the end of this function, we are going to negate isEven. Because if it was even, now it's not even. If it wasn't even, now it is even. That should make sense every time we add a number. And what we're going to do is, the first thing we're going to do is we're going to check whether or not it's even. If it's even, we're going to do some stuff. If it's not even, we're going to do a different set of stuff. Now, if it's even, what we want to do is we want to ensure that we basically first we want to do bigger.offer our number. Now, what this does is we basically take our number, our num, and insert it into the min heap, which is storing values larger than our median, okay? But now, to make sure everything's balanced and all the numbers are where they're supposed to be, in our smaller heap, which again is our max heap, storing all of our numbers less than our median, we want to offer the head of our bigger heap, okay? So pull, this function basically takes out the heap, reheapifies the heap, and now we returned an integer, and we can just pass that into the call to offer. Okay. Now, if we're in this else block, we want to basically do the opposite. So we want to do smaller.offer num, and then again, to make sure things are balanced, we want to do bigger.offer smaller.pull. Okay. And now that function's done. Now for our find median, we again have to check whether or not it's even is true. And if it is true, well, we have an even number of integers in our object, so we have to do this little calculation here, right? So what we want to do is we want to return parentheses smaller.peak to get the head of the smaller heap. And when I say the smaller heap, I mean the max heap of all the numbers that are smaller than the median, plus bigger.peak, so the head of the other heap. And we want to divide that by 2, right? Because we want to get the average, and we actually want to divide it by 2.0 because we want to float. And if it's not an even, well, we're going to just return smaller.peak. And the reason being is because if it's not even, we're always going to have one more item in our smaller heap than we are in our bigger heap. And that logic will make sense if you just look here. Our very first addition to our object, the number is going to actually end up in smaller, right? Because we first offer it to our bigger heap, and then we just, take it right out of our bigger heap and offer it in our smaller. So we're always going to end up, if there's an odd number of items in our object, with one more integer in our smaller heap, okay? So that is our solution. Let's see if I messed anything up. Bigger equals... Yeah, I missed the new word, didn't I, in both of these? There you go. So that's how we solved that one. That was day 66. If you guys liked that video, please like and subscribe. We'll be back on Monday with day 67. Take care, guys.